Hello, I had some trouble with the last proof that Sao did for logarithms, the last property of logarithms, and I found it easier to make an alternative proof which does not use the logarithm symbol at all. My English is not very good, so please bear with me. So the idea is this. If we say that x to the power of n is a and x to the power of p is b, then we could safely say that an n root of a equals a p root of b, which equals x. This we can derive from the properties of exponents, and also from the properties of exponents we can derive that this is the same as saying that a to the power of 1 over n equals b to the power of 1 over p, which equals x. And so if we say that n root of a to the power of p, that would equal to b, this is just properties of exponents and equations that come into play here, which give us this result. And this is another way of saying, if we use the exponent rules, this is like a to the power of p over n equal to b again. Now, so if we suppose that we're solving some sort of equation which tells us that a to the power of q is b, we can use the fact that this q is actually p over n and say that this equals to this, which is derived, and these are derived from this here, and maybe I should zoom out a bit so that it's more visible, like that. So it becomes even more clear if we substitute it with real numbers. And let's suppose we assume that 2 to the power of to the second power is 4, and 2 to the third power is 8. Well, obviously, maybe I should choose a brighter red. Yes, well, obviously, the square root, not the square root of the square root of 4 multiply to the power of 3 would also give us 8, So we could be asking 4 to which power gives us 8, and this would be the answer, this here, because it's the same as saying that 4 to the power of 3 over 2 gives us 8. And it's really so, because the square root of 4 is 2 to the power of 3, which gives us 8 indeed. So this here is the same principle applied. We want to know this, and we have this. So what Sal said is that we can use this with logarithms in calculators. Well, let's suppose if we have 7 by which power gives us 49. If we know that 10 to the power of n gives us 7. And if we know that 10 to the power of p gives us 49, this would mean that this is the same as saying 7 to the power of p over n. Yes. And indeed, if you try it with a calculator, the calculator would give you, it would give you this number, it would give you this number, and then you could divide them and you would get the answer. And it works for even more complicated numbers. You can test this out. But the point is that this is the walk function in a calculator. And that's all.